Hello everyone, myself SM Chetan Kumar. I am MSc Chemistry. Today I am going to explain briefly about periodic table and its elements. Now it begins. Periodic table. Periodic table may be defined as the tabular arrangement of elements in such a way that the elements having same property are kept together. In mid 1800s, the scientist Mendeleev discovered that the Mendeleev's periodic table is based upon the Mendeleev's periodic law, which states the physical and chemical property of the elements are a periodic function of their atomic masses. At the time of Mendeleev's, only 63 elements were known. This periodic table is divided into 7 horizontal rows is called periods and 8 vertical columns called groups. Zero group was added later on this modified Mendeleev's periodic table. The scientist Andrew Moseley in 1913 he determined the atomic number of elements and arranged the table in order of increasing atomic number. And the next topic is earlier attempts to classify elements. Many attempts were made to classify the known elements from the time to time. The earlier attempts are as follows. Proud's hypothesis. In 1815, according to this theory, a hydrogen atom was considered as the fundamental unit from which all other atoms were made. It is also known as unitary theory. Then Dauber-Reynolds trade. In 1829, Dauber-Reynolds classified the element into group of three elements which similar property in such a manner so that the atomic weight of middle element was arithmetic mean of the other two. We have example elements lithium, sodium and potassium. The atomic weight of these elements are lithium has 7, sodium has 23 and potassium has 39. The mean value of atomic masses can be calculated by adding of two elements, the lithium and potassium atomic weight. The lithium atomic weight is 7 plus the potassium atomic weight is 39. These two be added and divided by 2 will get 23, which is the atomic weight of sodium. Similarly, the chlorine, bromine, iodine and calcium, strontium, barium are two more examples for such traits. The next is Newland's octave. It is also called as law of octaves. In 1864, Newland stated that when the elements are arranged in order of increasing atomic masses, every 8 elements has properties similar to first, just like in a musical notes. There will be the illustration. Then this is the modern periodic table. The classification of the elements in a periodic table will be the modern periodic table consists of 18 vertical columns called groups. Here 1 to 18 is a group and 7 horizontal rows called periods. The first period contains 2 elements, hydrogen and helium. The second period contains 8 elements, lithium to neon. The third period contains 8 elements from sodium to argon. The fourth period contains 18 elements from potassium to krypton. The fifth period contains 18 elements from rubidium to xenon. The sixth period contains 32 elements, and then the seventh period is incomplete. On the basis of electronic configuration, elements are classified into 4 blocks known as S, P, D and F block. First and second group elements are S block elements. The general electronic configuration is NS1 to 2. The 13th and 18th group of elements are called P block elements. The general electronic configuration is NH2 NP126. The third to 12th group elements are called D block elements. The general configuration is N-1 D1 to 10 NS1 to 6. The periodic table has two rows at the bottom that are usually split out from the main body of the table. These rows contain elements in a lanthanoids and actinoid series, usually from 57 to 71, from lanthanum to lutetium, and 89 to 103, from actinium to lawrencium is actinoids. The lanthanoids and actinoids elements are called F block elements. The general electronic configuration is N-2 F1 to 14, N-1 D0 to 1, NS2. And we move to the classification of periodic groups. The classification of periodic groups are alkali metals, alkaline earth metals, transition metals, lanthanoids, actinoids, halogens, and noble gas. Then the classification of chemical groups. First, they are called alkali metal because they react with water to form an alkali solution, which is basic in nature. Then they are very reactive. The group 2A are called alkaline earth metals because they are reactive but not as reactive as group 1A. They are also soft metals. Group 7A are halogens. These need only one electron to fill their outer shell. They are very reactive. Group 8A are noble gas as they have completely filled outer shells. Then they are almost non-reactive. Now we discuss about alkali metals. Group 1 periodic table. These are present in group 1 periodic table. These alkali metals are very reactive and these are soft solids. These readily combines with halogens. This tendency to lose one electrons. For example, sodium, potassium, cesium. Next we have a topic about metals. The characteristics of metals. These are high electrical conductivity. These are high lusters. These are ductile and malleable. On the left side of periodic table, except hydrogens, and these are solids at room temperature. Then alkaline earth metals. Alkaline earth metals present group 2 on periodic table. These are abundant metal in earth, not as reactive as alkali metal, for example magnesium and strontium. And non-metals. The characteristics of non-metals are these are present in the upper right corner of the periodic table. These are non-lustrous. These are poor conductor of electricity. Some oxygen and chlorine are the gases at room temperature. Others are brittle solids. Then halogens. The halogen present at group 17 on periodic table. These halogens are salt formers. These combines with group 1 and 2 to form a salt, and between these will be ionic bond. For example, fluorine, bromine and iodine. Noble gases. These are present at group 18 on periodic table. These noble gases are relatively inert or non-reactive. These noble gases at room temperature. For example, helium and argon. Metalloids. The characteristics of metalloids is the element that lies on the diagonal line between the metals and nonmetals. Their chemical and physical properties are intermediate between the two. They share a properties with both metals and nonmetals. For example, silicon and germanium are very important semiconductors which conduct electricity. Lanthanoids. The characteristics of lanthanoids. These lanthanoids part of inner transition metals. The soft silver metals. The lanthanoids are the element from 57 to 70. For example, cerium and europium. Then I have a topic about actinoids. These actinoids are radioactive elements. These are part of inner transition metals. The element from the 89 to 102 are actinoids. For example, uranium and plutonium. Then the periodic table properties and their trends. The periodic properties may be defined as the property of the element which are directly or indirectly related to the electronic configuration of their atom and show gradation increasing or decreasing. In moving down the group or a longer period, the common physical property of the elements are atomic radius, ionization energy, electron affinity, electronegativity, valency, a metallic character of element, a non-metallic character of element, reactivity of the elements, a melting and boiling point of the elements. Now we are discussion about atomic radius. Atomic radius or ionic radius is generally defined as distance between the central of the nucleus and the outermost shell of the electron in an atom or an ion. The periodic trend of atomic radius across a period as we move from left to right in a period, atomic radius gradually decreases. Reason as we move left to right in a period, the atomic number of the element increases, so nuclear charge increases, while the number of shells in element remains the same. Across the group, on moving top to bottom in the group, the atomic radius gradually increases as nuclear charge and number of shells also increases. Ionization energy. The periodic trend of ionization energy across the period as we move from left to right in a period, ionization energy gradually increases. Reason as we move left to right in a periodic, atomic size or atomic radius decreases while nuclear charge increases. Example, exceptional beryllium possess more first ionization energy than boron. Because the beryllium has a half-filled s block orbital and more energy is required to remove the electron from the half or completely filled orbits. That is why noble gas are also exceptionally high ionization energies. Then ionization energy across the group. On moving top to bottom in a group, ionization energy gradually decreases as the atomic radius increases. Electron affinity. Electron affinity or electron gain enthalpy is the amount of energy released when isolated gaseous atom accept an electron to form a monovalent gaseous anion. The periodic trend of electron affinity across the period as we move from left to right in a period, electron affinity gradually increases. Reason as we move from left to right in a periodic, atomic size or atomic radius decreases while a nuclear charge increases. Then across the group, on moving top to bottom in a group, a electron affinity gradually decreases. Electronegativity. The electronegativity is a tendency for an atom of a given chemical element to attract shared electrons or a electron density when formation of chemical bond. The tendency of an atom to attract electron of another atom. The electronegativity of across the period is as we move from left to right across the period, the electronegativity increases in a periodic table. Fluorine is the most electronegative element. A reason as the nuclear charge increases of an atom, its electron loving character also increases. Example across the group, as we move top to bottom in a group, electronegativity decreases. Then valency electron. The valency electron is an electron in the outermost shell associated with an atom and that can participate in formation of chemical bond if the outer shell is not closed. The valency electron is across the period as we move from left to right across the period. In the periodic table, the number of valence electron increases. Across the group, the valence electron remain constant. It means the elements present in the same group have the same number of valency electron. For example, hydrogen, lithium and sodium elements are present in the first group and have the same number of valence electron, which is 1. Then valency. Valency is a combination capacity of an atom. Valency are moving left to right across a period in a periodic table. First valency increases then decreases. Across the group, there is no change in valency across a group. The element of same group shows a same valency. These will be the table of valency. Atomic number of lithium, barium, boron, carbon, nitrogen and oxygen and fluorine. Atomic number of lithium will be 3 and barium is 4, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8 and fluorine is 9. The valency of lithium is 1 and barium is 2, boron is 3 and carbon has 4. Then the valency of nitrogen will be 3, oxygen will be 2 and fluorine is 1. A metallic character of element. Metallic character of element as we move left to right across a period in a periodic table, a metallic character of element decreases. Across the group, as we move top to bottom in a group, the periodic table of the metallic character is increases. A non-metallic character of the elements. As we move from left to right across the period, the periodic table is non-metallic character of the element increases. As we move top to bottom in a group, the periodic table non-metallic character is decreases. Reactivity of elements. The reactivity of elements depends on its electropositive characters. So, more is the metallic character, more is the electropositive nature of the element, and more is reactivity. As metallic character decreases across the period, left to right, so reactivity also decreases. Although the reactivity of non-metals increases on moving left to right across the period. Thus, we can conclude as we move left to right in a period, the reactivity of element gradually decreases upon to the group. The 13 and then the start increase. A melting point and boiling point of the elements. The melting and boiling point of the element decreases gradually from top to bottom in a group, while melting point of boiling point of a non-metal increases on moving from top to bottom in a group of the periodic table. This will be the flow chart of the properties of a element. On the basis of electronic configuration, elements are classified into four blocks known as S, P, D, and F block. The elements of group 1 and 2 constitute S block. In these elements, differentiating the electron enters the s orbital of n shell. The general electron configuration of s block elements is ns1 to 2. The next is p block elements. The element of group 13 to 18 constitute p block. In these elements, differentiating electron enter the p orbital of n shell. General electron configuration of p block elements is ns2 np1 to 6. Then d block elements. These also called as transition element. The third to 12 group of elements are called d block elements. In these elements, differentiating electron enters the d orbital of n-1 shell. The general electron configuration is n-1 d 1 to 10 ns 1 to 2. Group 12 elements like zinc, cadmium, and mercury are not considered as transition elements. Thus, they are d block elements because the transition element is defined as the element which possesses at least one unpaired electron in its free state or one of its stable oxidation state. F block elements. These elements are also called inner transition elements. The elements in which the last electron enters f orbital of n-2 shell are called F block elements. The F block has two series 4f and 5f. Each series has 14 elements. These comprise two horizontal series placed at bottom of the periodic table to avoid an unnecessary expansion. F block elements collectively are also known as rare earth elements. The general electron configuration is n-2 f1 to 14 and n-1 d0 to 1 and ns2. The lanthanoids and actinoids belong to a 6th and 7th period of third group respectively. These elements present between two transition elements. Therefore, they are called inner transition elements. This will be completion of periodic tables and its elements. Thank you.